In this video, we are still on series and parallel resistors. We'll now be dealing with this chain of series of parallel resistors. So let's see how to solve this step by step. So this is the source, and then let's say that this is the return path for the current. So we have that this, we are tracing from here. We met a junction, right? So this junction is in parallel with this. So this resistor is in parallel with to this resistor. So, and then we still move. We met another junction. We see parallel, and all these confusing things. Which ones are in parallel? Which ones are in series? So for this, we keep on tracing until we met this last path. We can see that these three are in series. So that is where we are going to start. When we now resolve these three as in series, we can now see we can represent it with one resistor. And when we do so, we can see that that one resistor is in parallel with this. And then we now resolve the two to get a particular resistance that will be here. We can now see is now in series with these three. And then when we do that, we can resolve them to get one resistance that is in parallel to this. And then let's just stop the whole story and get into action. So we'll be redrawing many times as possible. So don't be confused, don't panic. It's still as easy as it is to solve circuits this way. Okay. Now we agreed that we are going to start with this very last part because they are in series, so it's easy to do, and we already know how to do the series addition of resistances, right? So we have that is equal to 10 plus 10 plus 10, that's the 3, which is equal to 30 ohms. So this 3 is just like saying we have one piece of 30 ohm resistor. So we are going to redraw. Okay, we've redrawn the circuit with this. So we have that this 30 ohms here, that's the one we resolved this set of 3 series resistances to be equivalent to. So we can see that now. So this is redrawn. We can see this corner is this corner, right? And we can see this is this, right? So this is just, we now replace this with this. Okay, so we can now see, starting from this end, remember this is 10 ohms, this is 30 ohms, we can actually see that what we have here is two parallel resistors, like at this end. So let me draw a boundary line to show us where we are actually looking at. We can see, all we can see is this at this end, and we have to get the equivalent resistance for these two. Very good. So it's just 1/10 plus 1/30, which is equal to 1/30. We have 3 plus 1, which is 4/30. So we have that. When we get that, we have 30 over 4. 3 plus 1, that is 4. So at the end of the day, when we do the reciprocal, we get 30 over 4, which is equal to 7.5 ohms. So this combination of these two is equivalent to 7.5 ohms. Now we are going to redraw to make this simpler further. So it's just tiny steps that will get us to actually solve this thing that looks complex in an easy way. Okay, moving on. We can see we've redrawn. With these two, we've resolved, getting the equivalent resistance to be 7.5 ohms, just like we solved here. So we can see that this part is actually equal to this part exactly, right? You could see that. Then this now represents this combination, right? Good. So just like we did at first, we can see when we trace, we get to the last part, and we can see that these three are in series to each other. So we have to get a boundary line once again to show that these three resistors that are in series are what we are going to resolve. So they are series resistor 10, this 10 plus 7.5 plus 10, they are all equal to 27.5 ohms. So this combination is 27.5 ohms. Now we are going to redraw in order to just have this combination as one. As we can see, our circuit is getting easier and simpler and smaller, of course. So we've resolved this to be 27.5 ohms, so we've redrawn, right? So we can see that this is parallel connection. And then for us to solve, we have to say that 1 over the effective parallel resistance, that's this 2. Let's just get a boundary mark to show that these are the two we are adding at this point, is equal to 1 over 10 plus 1 over 27.5. And when we have that addition, we are going to get 7.33. So we have that the reciprocal of this, which is this, is equal to 7.33 ohms. So this combination gave us 7.33 ohms. We are now going to redraw once again. I know it's a long process, but that's just how to make these things easier for us. And as you can see, you're just flowing with the whole thing. And now we can see, even like you just know that you're done, because all these are now in series with each other. So the final resistance, let me just call that RT to represent R total. The total effective or equivalent resistance is now equal to 10 plus 7.33 plus 10. So that is 20 plus 7.33, which is 27.33 ohms. Finally, so what we just have to do is to neglect the very long process and focus on understanding each of our minute steps. Okay, so let's see where we started from. We started from this long complex thing, right? And then it reduced progressively until we got to the final part where we just have all this. So we can see no matter how complex a circuit is, we can as well just go ahead and get it to be in the form of series and parallel simple connections that could get you this. Okay,